Welcome to the weekly science dump. After a quick message from our sponsors, we will be discussing heat. There are three main ways that heat can transfer. The most obvious one would be conduction, the transfer of heat via direct contact. The heat wants to be equal, just like pressure, so it tries to distribute evenly. The hot box on the right is losing thermal energy to the other box, so the second box would feel rather cold to the hot box. Notice how the bottom set is nearly reaching an equilibrium, but the top one is still struggling? This is because heat flows through certain materials better than others. This is the material's conductivity. The set of boxes on the bottom are more conductive, and the heat distributes quicker. But why would certain materials conduct heat better? The answer is density. Higher density means the molecules are closer together, making it easier for heat to flow through. The hotter something is, the lower the density gets, since the volume increases but the mass stays constant. Another heat-related property of materials is thermal inertia. Thermal inertia, or specific heat capacity, is the material's ability to resist changing temperature. Here, the box on the left has more thermal inertia, so it will cool slower. The second type of heat transfer that comes to mind is radiation. The central molecule is spewing out hot particles in random directions, and when another particle is hit by one of these particles, it warms up by a little. So look outside the window. Notice a heat source that uses radiation? While we're on the topic of light, recall that the red light didn't warm the red brick in the gizmo. This is because the brick is mainly being bombarded by red light with some green and blue light. The brick absorbs the green and blue light, making it hotter, but the red light just bounces right off. Now, let's introduce our third and final candidate.
Did you know those plate tectonics move real slow? There's convection.
Wait, stop it right there. Convection. It's the third and final method of heat transfer. As I'm sure you all know by now, hot air rises and cold air sinks because the hot air is lighter. If we add a heat source at the bottom, say a fire, the cold air that sunk to the bottom would heat up and rise again. Meanwhile, the hot air that rose cools down and sinks to the bottom to be reheated. It's a cycle. And with that, we have discussed all three methods of heat transfer. And this concludes this week's segment of the Science Dump. The Science Dump is produced and directed by Grant Yen. Thank you to the internet for basically anything and Monty Python for comic relief. And this is NPR.